Hello and welcome. This video will describe a project done for a Midwest retailer by a senior design team of students in the Industrial and Manufacturing Systems Engineering program at Iowa State University in the spring of 2018. The students in this senior design group, known as Group 8, are Matt Franzak, Kate Johnson, Cole Thompson, and myself, Nick Frank. The name of this project is Fleet Fuel Economy Improvement Project. Let's start with the objectives and overview. The Midwest retailer has 220 trucks, 482 trailers, and 416 drivers. Their current fuel economy, as described by the retailer, is 6.67 miles per gallon. The one found by the group is 6.69 miles per gallon. Their fuel economy used to measure the factors applicable when trailers are moving is 6.84 miles per gallon, and the retailer's goal is to get to 8 miles per gallon for the fleet. These are the tools used in this project. The deliverables that the Iowa State Senior Design Team will hand over to the retailer are the following: a ranked list of factors that affect fuel economy, an in-depth analysis of driver behaviors affecting fuel economy, and a recommendation on which aerodynamic trailer feature this retailer should use.
One of the team's deliverables was to figure out which factors were the most important when looking at improving fuel economy. To do this, the team took two data sources and combined them into one master workbook. After starting with 39 different variables, the team needed to cut this down to 17 variables in order to run one full regression in Excel. Many regressions were conducted with a thorough elimination process according to each variable's p-values and t-stat values. The final regression resulted in an r-square value of 0.55, which is not as high as the team would have hoped, but this means that there are more variables which were not recorded that play a significant factor in predicting fuel economy. The sign of the coefficient tells us the relationship with miles per gallon. For example, the greater the miles on the odometer, the more negatively it will affect fuel economy. Moving engine load percentage proved to be the biggest contributing factor, and this will give the company a more focused approach when making improvements in the future.
The second area of analysis was on driver performance. The first section of this analysis was to create a system to rank drivers. The team created a scoring system that evaluated performance against the average on each tractor. This generated a ranked list of driver scores. The distribution of scores is shown on the graph on screen. The team used this score to sort drivers into the categories of above average, average, and below average. In order to determine which behaviors contribute to driver performance, the team ran a code in RStudio that used decision tree analysis. The results showed that driver characteristics are better indicators of performance than driver behaviors. The team's recommendation to implement a one-day driver training was based on industry research, which shows that it can improve fleet fuel economy by 5 to 20%. The analysis showed that the training should focus on speed, braking, and top gear time.
The last deliverable was to analyze different trailer features. There are three types of trailer aerodynamic features that the team initially analyzed: smart trucks, skirts, and blank trailers. A smart truck and a skirt are both add-ons that were purchased with the trailer. Also, to improve fuel economy, the Midwest retailer put fly swatters, super singles, or vortexes on random trailers. After analyzing over 40,000 trips in 2017, the best fuel economy was shown on a trailer skirt, followed by a smart truck, and then a blank trailer. The team was able to prove that the confidence interval for a trailer skirt didn't overlap with any other trailer feature with 99% confidence. Lastly, the team was able to prove that the fly swatters, super singles, and vortexes that were added onto trailers did nothing or little to improve fuel economy.
The team had three final recommendations. The first is that the Midwest retailer should install a skirt on all blank trailers and should use skirts on all new trailers. The second recommendation is to implement a one-day annual training that will improve the fleet's fuel efficiency and improve the company's safety measures. The last recommendation is to keep an updated running inventory of all of their trailers. After implementing these three recommendations, the Midwest retailer can expect to save over $740,000 over a 3-year period, resulting in a 6-month payback period. Thank you for listening to our Spring 2018 Senior Design Project.